What's up, y'all? Algebra 2, Thursday, March 19th. We're going to do some log review today. So we're going to go over what it means to be in log form. We're going to go over the 3 rules of logs, and we're going to solve some log equations. So remember, if I have something like this, let's say I had like 5 to the third equals 125. That's an exponential form right now. So if I wanted to write it in log form, this is the base. This will actually be the product, which will go inside the parentheses, and this will go on the other side of the equal sign. So it'll be in log form, log base 5, we say of 125 equals 3. So again, this is the base, this is the product, this goes on the other side of the equal sign. I might have said that wrong the first time. So we can also work backwards, and we could have something like this, like, I don't know, log base 2 of 16 equals 2 times 2 is 4, times 2 is 8, times 2 is 16, so that'll be 4. So if I wanted to write that backwards, it would be the exponent 2, which is the base. Sorry, the base is 2, the exponent is 4, equals 16. Okay, so that's just going between the two. Log form and exponential form. That takes care of the first one. 2, 3 rules of logs. So the first rule of logs, if you have something like this, rule number 1 of logs, if you have something like this, log of, I don't know, like 3x. So this is one log. If you wanted to break it up into 2 logs, remember multiplication with 1 log is actually addition with 2 logs. So it'd be log base 3 plus log base x. Okay, same thing goes for division. So if I had like log of like x over y. Division with 1 log is going to be subtraction with 2 logs. Log base x minus log base y. And then finally, the third rule, you can take an exponent. Let's say I had log of like x to the 4th. You can take the exponent and you can drop it in front. So you can have something like this, like log, drop the 4 in front, put the x on the inside. So 1 log multiplication becomes 2 logs addition, division becomes subtraction, and we can take the exponent and drop it in front. So now what we can do is we can take those and we can kind of combine them into one. Let's just do an example here. So let's say I had log of like, I don't know, let's say I had x squared y over, I don't know, 3z, something like that. And I wanted to write it expanded. So these can kind of get a little bit long. What I would do first is I would take this and I would break it up into my 2 logs through subtraction, because division means subtraction. So it would be log base x squared y minus log base 3z. Now it's important that when you split this one up into addition, that the negative gets distributed to both. So I'll show you that in a second. So here, multiplication, that can be split up into 2. So it'll be x squared plus log y minus, this will become, this multiplication will become addition. So log base 3, or sorry, log base 10 of 3 minus, that's where you guys are going to get confused or caught up, log base 10 of z. I got one more thing I can do here. You can take this 2 and you can write it in front. So this 2 can pop down in front. So the first one, to go from here to here, we used rule number 2. To go from here to here and here to here, we used rule number 1, and now we'll use rule number 3. So it'll be 2 log x plus log y minus log 3 minus log z. And that's it. Now if we wanted to, we can go here and we can work backwards too. I think the delta math, though, is just going to work from here down to something like that. And then finally, the last one, so we are good there. Last one is using these to solve equations. So let's do this over on this side. So let's say I had something like this, like log base 3 of 2x plus log base 3 of 5 equals log base 3. We'll just say 10. That looks good. Okay, so the problem is that we need to write this. We don't know how to solve things like this. They're in log form, so we need to write an exponential form. So this is kind of combining this and this into one step. So again, if I have multiplication, or sorry, if I have addition with 2 logs, I can make that multiplication log base 3 of 2x times 5 with 1 log, so it gives me 10. So that's going to be log base 3 of 10x equals 10. And now finally, my last step here is I can take this and I can write it in exponential form. So it's in log form. I don't know how to do that, but I can. I call it carouseling. So we go 3 to the 10 equals 10x. 3 to the 10 is going to be a giant number. Let's find out here. So you know what? We can either leave it 3 to the 10th. Let's see if it'll do it for us. Oh, well. 3 to the 10th is 59049. So then we just divide both sides by 10, and we get x to be 5904.9. Okay, so I like that because it uses the things that we did in our second learning target here, combined with things we did in the first learning target, and that gives us our third learning target. Okay. All right, good stuff. See you soon. Peace.